I'm not sure what's going on here, but the room is extremely hot. So I'll work one problem. I don't know why you would want to turn on the heater at this point. Give it a second. Check the screen, make sure we're okay. Uh-oh. So, something's up here. Ah, here we go. So let's roll on. Oh, I did, but I did not. Yeah, I did the acceleration. So let's go on to the next section. 6. All right, let's go on to this one, or for that matter, okay, let's do, well, let's start with that. Okay. So it says determine the displacement. Let me make sure it sees it on the screen. Where is it? So there we go. Okay, so it's doing okay. It says determine the displacement of the log. The truck at C pulls the cable 4 foot to the right. It doesn't look like it, but that's the log. So I left this one on there, and so what I'm going to do is scroll the screen up. To the point. Yeah, I think I can see everything there. Hang on, I'll take a pause for a second. I'm going to look and make sure. Hang on. Okay, here we go. I had to go stand by the fan for a second. Let me make sure the stream is going okay. Hang on. And I think I'm back. All right, so let's go ahead and do this. So we have the length of the road. There happens to only be really one road. There is this road, but we're not interested in that one. He has put a datum right here. We could do it a different way, but the datum is a point which doesn't move, so that's this part right here. So this is a zoom in of this, where he's picked an arbitrary spot, maybe wrapped a piece of tape around it, you know, kind of did something like that, and said, okay, we're going to go with that. We're going to look at the length of the rope from here all the way to here. That's the length of the rope. He's not considering, doesn't want to consider that part. You could if you wanted to, but it's just a waste of time. So, you know, as the truck moves to the right, this point moves that way too. So, let's look at the length of the rope, okay? There are these portions right here and right here that don't change at all. Those lengths are fixed. I'll just call those a little delta. So the length of the rope is the delta, which is this one and that one, plus this length, which happens to be SB minus SA. I'm sorry, that's a C. SB minus SC gives you that length. And we're going to consider this to be part of the rope as well. So it'll go ahead and go to the center of the pulley. And then we've got two SBs. So that's the length of that rope. Now, you can take the differential, I guess I'll call it L, of L with respect to time. It doesn't change. Fixed length through time. Oh. So we have a fixed length through the time. So dl dt, 0. This part, equals to, let's do this. Then we'll do, I got a B, I got 2B, that gives me 3 B's, minus SC. Now, take the dot, where actually the definition of the dot is time derivative. You've seen that before. Y is a function of x, y prime is equal to dy dx. Y is a function of time, y dot is equal to dy dt. Very similar, so there's a lot of dots in here. Okay, now it doesn't change. It turns out this becomes 0 because the length of the rope that is from here to here, here to here, doesn't change through time. Only way it would change through time is if the diameter somehow changed through time. That's not going to happen. So what you end up with is this. Minus SC dot. If you move the SC over, you get 3 SB is equal to SC. Now that is the speed, the velocity. The velocity of this point right here and the velocity of this point right here. So if you want to identify it on the original diagram, the 2 points are this and some location, say maybe right here. Piece of tape around the rope, so if this is going, so he says, we want to know the displacement of the log if the truck moved at C, pulls the cable 4 feet to the right. Now, I found the velocities, but what we don't have is we don't have time. So if I assume that this occurred in 1 second, then the replacement of the log, if the truck at C pulls the cable to the right 4 feet. So we have this label SC, we have a piece of tape wrapped around the rope, say, this is my location C, it moved 4 feet, but I arbitrarily said it did it in 1 second. During that same 1 second, what happened to B? So, if that's the case, SC dot equals to 4, and 4 divided by 3 is SB dot. If this occurred in 1 second, then it moved 4/3 feet in that same very second, meaning that that thing moved 4/3 to the right. Now, let's see if we're right. Right meaning correct. Okay, 4/3 and 1.43, I'm sorry, 1.33, 4/3, same thing as 3 plus 1/3, or 1 1/3, which is that. So, let me pick up a more interesting one out of the book, maybe. I guess I could do one more. I don't know why they have the heater running in here. Well, let's go ahead and do this one, because this one is okay. Looks like on the stream there's this spot right up here that gets blocked by the projector, and I can't get this other silly camera to work. Okay. Determine the constant speed at which the cable at A must be drawn by the motor in order to hoist the load 6 meters in 1.5 seconds. So 6 meters, seconds. We can multiply both by 2, or 4 meters per second. And this is the cable A must be drawn, hoist the load. So that means this point is moving at 4 meters per second. You know what? I think I'm going to move that thing up here. Give me a second. I'm moving the thing up. I hear something happening with the air conditioners. Okay. All right. Okay. I don't think the fan is in the way. Okay. All right. So let's move ahead. So, one of the unique things here is I have a rope here that is called 1. I'll call this rope 1. I'll call the second one rope 2. I'll call this last one rope 3. At this point, let me see if we can see. You can see that on the. So I'm looking at the stream. It looks like you can see that. I'm going to pick a datum. Sit still and is right there. SA. Here's a pulley. It's already labeled for us. It's labeled D. This one's labeled C. This one's labeled B. That's rope 2. I'm moving that out of the way because I need these locations. This will be SD. This will be SC, and this will be SB. Let me make sure SB, yeah, you can see that. All right. So I know the stream is about 5 seconds behind, so sometimes I take a pause to make sure nobody here minds. So now let's take these and go through these. There are 3 ropes. Length of rope 1, length of rope 2, and length of rope 3. Rope 1, I've labeled as this. So I'm interested in, first of all, there's a generic delta associated with the pulleys in there. Example, if I'm looking at rope 3, there's a delta, there's a delta. This arc, that arc, neither change length. So I list these because rope that touches the pulley does not change in length. So that's what these are. Then I start using the S's. Okay, so start using the S's. Since I've started with 1, I probably should work with 1. I got 3 down here, so I'll start with 1, which is this far rope here, goes over to here, comes up to this. The distance from here to there is SB. Okay, again, this is rope 1. So the rope 1 goes all the way down, comes up to right here. I'm looking at the length from here to here. Then I have the length from here to here. This is SB minus SC. That is that distance. SB is the distance from here to here. That takes care of the length of rope 1. Rope 2 is this part. I'm not considering, or this one, these could be thought of as being in the deltas. So the rope that touches the pulley doesn't change in time, but also this top rope doesn't change in time either. So let's look at L2. It's this. I go from here to here, that's SC, plus the little section of rope that goes from here to here. That is SC minus SB. Oops, SB. I'm assuming you saw the videos that describe this on Blackboard, so that's why I just start the work bottom. I'm done with rope 2. Now I'm only looking at rope 3. That's the part that goes up over this pulley, back down, and back up here. A little bit more complicated. I have an SD. I have another SD. 2 SDs. I have this one and that one. Then I have this one, SA. Now, what I'll do is go through this, say L1 dot, L2 dot, L3 dot. The rope itself does not change in length. The deltas do not change in length. So they are 0, 0, and 0. These, however, all these terms do change in length. So we have SB dot plus, and I might as well put these two together, 2SB dot minus SC dot plus this one and this one go together, and then this one's just by itself. Now, he has told us, determine the constant speed at which the cable A must be drawn. So what he wants SA dot. That's the cable. It must be drawn by the motor in order to hoist the load being this point, meaning SB. Now, you have to pay particular close attention. Why did I put a minus sign here? The direction from the datum to the locations is important, which means this is plus, this is plus, this direction is plus, and this direction is plus. He says that the cable must be drawn. I'm assuming being drawn means pulling towards you. If he didn't use the word drawn and used the word released, I might have switched the direction, but I don't know. It turns out if you use a plus, all it does is change the sign anyway, so it really doesn't matter. So if you look at this, and I may just truncate my explanation here and say, write the equations. Then, what do I have? I have SB. In other words, here's the flow, the rest of the workflow. I insert the value of minus 4 here. From that equation, I get SC. From SC, I insert it here. From this equation, I get SD. From SD, I get this equation. I insert it into here. I'll pull out SA. And I get the answer out of that last. So I just propagate down the things and get the solution. That's it. Okay. It is hot in here. I'll do just one more, and then okay. All right, so I'm going to erase that, move on. I think it was easily viewable there. I've been watching the screen. Let's do this one and call it a day before my body heat turns this room into an oven. Okay. Cable A is being drawn towards the motor. Being drawn that way at 8 meters per second. Determine the velocity of the block, being this thing. Again, datums. Again, in this case, you can draw your datums off the same pulley point, but this will be listed as A, that's A. This pulley will be SC. And then you got SB. There you go. There's your 3 things, 3 locations. How many ropes? It looks like I have 2. I have one that's joined from the center of this pulley over the top to there. I will label it 1. I will label the other one 2. And then what I will do is length of 1 is equal to, that being 1, will be the delta, of course, 1 plus the length from here to here, SC, and a length there and there, plus SA. Length of 2, the delta, S. We're looking at the length of this rope. We're not going to consider this, or it will be, think of it as this being embedded in the delta, rolls up and over that. Now, take a look. I get this length being SC. Okay, so if I'm taking this length from here to here, then I have 1, 2, and 3 of those. But what is that distance? That is SB minus SC. Again, this distance is SB minus SC. 1, 2, 3 of them, and you got that. Take a derivative, and you get this. That's 0, that's 0, L2 dot, that's 0, plus delta 2 dot, that's 0, plus, I'm going to go ahead and combine this with this one. There's 3 of them here, there's 1 of them there. 3 SB dot minus 2 SC dot equals 0 equals 0. Here's my 2 equations. Again, what do you do? It tells you the velocity A to the right. This being positive means that SA dot going to the right is equal to 8. What do? You put in 8 right here. Solve for SC. Once you solve for SC, you embed it right back in there. Solve for SB. It's that simple. Now, I've tried to work these a little bit faster, and it's kind of hot in here, so I may actually draw it to a close and say, I don't know why the building is so hot, but that's with the fan going straight up. So I'm sorry, I may just go ahead and cut it and say that we're done. That'll save this other problem. And maybe a couple more. I'll save these other 2 or 3 for Wednesday. Hopefully they'll have the air conditioning in here. So I'm going to go ahead and drop the screen.